word problem. This is circular measure.
Mm.
So actually, wait, can I type it out?
What do you mean by you cannot? Go to slide 11 and then just write on it.
I can see.
Yep, yes. Please go ahead. So while you are writing, let me just grab a glass of water. Yeah?
Okay.
Okay, good. Go ahead. Start with circular. You are talking about circular measure, right?
Yeah.
Okay. So to you, there is. I guess to you there is no distinction between A maths and E maths, right? For you, it's just maths, right?
Yeah. It's just math.
Okay, good. Yep. Go ahead. You have not written down anything yet.
Huh? I'm typing something.
On slide, which slide you are on?
11.
Okay, I don't see anything written. Okay, let me. Okay, it's okay. Can I try to write something on slide 11? Can you see?
Okay.
I have written something on slide 11 already.
Yeah, I can see. I think you can only see my.
Hold on, let me switch to my headphone. Yeah. Okay, so given that you are typing it. Okay, so it take a while lah, I guess. It take a while to capture your this. Can you hear me? Yep, yep, you can. Okay, good. Okay, so basically you are typing the question into the slide, so maybe it takes a while to load. That's why it's not as responsive as you write it out using the free form. Okay, no problem. Okay, so do you have problem with this question? Okay, so do you have problem with this circular measure type of question? Not really. Okay, then what about probability? Okay, I understand what this circular measure is about. Yeah. Hmm. Do you have questions about probability? No. Okay. Okay, lots. Okay. Then sounds good, sounds good. So since you have no problem, then we don't have to spend time on this too. So which one you want to have a good discussion on, then we will just talk about that, yeah. Mm. Binomial theorem. So okay, do you have an example of a, a, a a question so that we can talk about binomial theorem with that question? Mm, 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 mm. Yeah, please, please. Slide 11, right? Now you are writing it, okay. Mm, 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 mm. Mm. Okay, good. Okay, so how much? Okay, just want to understand how much you have understood binomial theorem before we talk about this question. Mm-hmm, mm-hmm. 2 days, okay. Mm-hmm. Okay, good. Okay, let me just go to slide 12. So let me just walk you through some of the basic concepts in binomial theorem. So with that, then maybe you can solve this question on your own. Okay. Okay, good. So I go to slide 12. Okay. Are you on slide 12 already? I will use any other color than I will use any other color than black. So you will use black. I will use any other color. I will use red first. Okay, so for this binomial theorem, theorem, or sometimes they call it binomial expansion. Okay, so there is a formula on the formula sheet that you can follow. Do you know that? Yeah. So yep, that one. Yes, that one. Yep. So I think okay. By the way, you do you know how to use that formula to solve binomial expansion question? Let me just give you an example. I think so. Y- you are in okay. So let's talk about most likely you are in sec four, the equivalent of sec four now. Okay, maybe you don't call it sec four in your school, but I think you are in the in the equivalent of sec four. Okay, your level right now. So before sec four, I think we learn about what is a linear equation. Okay, so linear equation is like y equals to mx plus c. Okay, where the degree of the equation is, or where the degree of this x is 1, x to the power 1 for this. Okay, so this is called a linear equation. So what's the meaning of linear? Linear means x to the power 1, or a to the power 1, or b to the power 1. Okay, so when your degree of the polynomial is 1, so it's called a linear equation. Okay, then of course we'll move on to a quadratic equation, right? Quadratic equation. So what is the general format of a quadratic equation? Yeah, so a is y equals to ax squared plus bx plus c. Okay, so the degree of the polynomial is 2 in this case, right? Okay, so that's called I mean this kind of equation is called a quadratic equation. And then of course we move on to cubic. Okay, cubic means x to the power 3, or the degree of the equation is 3. Then of course you move on to polynomial, right? I think you learn about polynomial. Okay, so basically uh, when you reach sec 4 and beyond, right? So there are questions that require you to solve questions like this, like x plus 1 bracket to the power of 12. How are you going to like expand this out? Okay, you can't tell me you are going to use this, right? You are going to use this, and then after that you continue to it does not make sense to do it this way, right? So that's the reason why you need to learn this binomial theorem or binomial expansion method, so that you can expand this to the power of 12 or and beyond. Are you clear? Okay, so basically, right, this topic, binomial theorem or expansion. So basically, if you have learned it well, so you have the tool to uh, expand any expression or equation to the power of more than 3. Can be the power can be 4, can be 5, can be 6, and beyond. And you know how to expand it with the help of this binomial theorem. Okay, so that's the reason why you need to learn binomial theorem. Okay, so let's start with a one example. Then we will talk about your question. Okay, so I'm going to slide 13. I hope you are on slide 13. You're on the same page. So basically, let's start with a easy one. X plus let's say 2 bracket to the power of 6. So um, I don't think you can expand this with existing methods. Okay, but with the concepts of binomial theorem, then you can actually do it. Okay, so okay, of course you can follow the formula on the formula sheet, but I kind of like come out with my method, which is a derivative of the formula. Okay, I basically I did not create this on my own, but I kind of like I learned from the formula, but I just condense it to a more easily understandable format. So now I'm going to demonstrate to you how I will expand this, okay, using my method, which is derived from the formula on your formula sheet. Okay, okay, so first thing first. So this x plus 2 bracket to the power of 6, right? So first thing first, how many terms are there? Okay, let's do a simple one. 6 is too many. So let's start with 5 to the power of 5. How many terms you will end up with if you expand this? Yes. Okay, so how do you know how many terms you will end up with? So you just ask yourself this simple question. For a quadratic, you end up with x squared plus 2x plus 1, right? So for power 2, you end up with 3 terms, right? And then this is in descending order. The powers in descending order. Can you see? So similarly, so it really depends um, um, what the question wants. So sometimes the question just leave it to you. Sometimes the question wants, okay, I want it to be in descending order, I want it to be in ascending order. Then you have to rearrange the terms according to the requirements. All right? Okay, so my way of doing it is very simple. So you know that this x plus 2 bracket to the power of 5, you will end up with 6 terms. So what you need to do is very simple. Just give yourself one, two. Okay, maybe I should write it smaller. I need to manage the space. Okay, 1, 2, 3, 4, 5. Okay, one more. Okay, so I know that, hey, I'm going to end up with 6 terms. Okay, then I just write. Okay, and by the way, these 6 terms, they will be summed up together at the end. So therefore I put a plus in between. Okay, so this is going to be your first, second, third, fourth, fifth, and sixth. And by the way, since the question never says whether I should sorry, since the question never says whether I should get the result in descending order or ascending order, I will just leave it to you. Either way, okay, either way, okay. So since for this expansion, I my result is in descending order, so most likely I will end up with descending order first. Okay, okay. So for each of the term, right? For each of the term, what you need to do is you need 3 brackets for each of the term. Later I will explain to you what you need to fill up in the brackets. Okay, but you need 3 brackets for each term. Okay, so basically this is very mechanical. Okay, you just have to remember this. Okay, power 5, 6 terms, and each term has 3 brackets that you need to fill up. And then you just have to follow this every single time next. Okay? And by the way, your school might teach you differently. It's okay. So you just learn from your school, you learn from me, you just find, okay, you just judge yourself which one is easier for you to understand. You just carry on with that method. Okay? Okay, so I have already filled up each term with 3 brackets. And now your job is to fill up the brackets. Okay? So the first thing you fill up with is, okay, now go back to the question now. Can you see that this is what? This is x plus 2 to the power of 5. Okay? So to me, x and plus 2, right? X and plus 2, right? They always fill up the second bracket and the third bracket. So second, third, second, third of each term. So are you following? So far so good? Okay, so if you have x plus 2, okay, so you just fill up accordingly to the way I have done so far. And then then you must be wondering, hey, then the first bracket of each term is unfilled. So what do I need to fill up with? Then the 5. And over here, right, I think you notice the 5 I have written so far is actually on the top level of the first bracket. Okay? So then what do you do next? What do you do next? Okay, if I'm not wrong, you always start with 5 choose 0. And then 5 choose 1. And then 5 choose 2, 5 choose 3, 5 choose 4, and 5 choose 5. Okay, can you see can you see how it works? Then what do? You don't get the plus 2. Oh, okay, good. So by the way, the lesson is recorded. So okay, so you understand how do I fill up the first bracket? That means basically you don't understand this plus 2. Okay, maybe I use a different. Okay, let me do it one more time. Let me just erase it. The lesson is recorded, so if you want to do some self revision or home based learning, you can do it. Yeah. You have the link to the videos already. Oh, okay. I will send you one more time. You just have to bookmark it, because I remember I sent you, I think, several times in the past, maybe 2 times already. But never mind. Okay, so you have x plus 2, right? Okay, so the x plus 2 you fill up. Okay, the x will come to the second bracket. Okay, let me use a different color. The x will come to the second bracket of each term. And then the plus 2 will go to the third bracket of each term. This is the way, I mean, it just this is the way it is. Okay, I have not, I mean, I didn't invent this. Okay, so are you clear how you should fill up the second and the third bracket of each term? The plus 2 means it means it's a positive 2. Oh, yeah. You can write it as 2. But if over here, right, if let's say instead of x plus 2, right, if it's minus 2, x minus 2, then you have to write minus 2 inside. So that's why it's always good if it's plus 2, you just write plus 2 inside lah. Because you see 2 2 to the power of 3 versus is equal to plus 2 to the power of 3. Okay? Okay, so do you know how I fill up the second and the third bracket of each term already? Okay, good. Then next is like I say, then you the first bracket of each term is 5 choose 0, 5 choose 1, 5 choose 2, 5 choose 3, 5 choose 4, and 5 choose 5. So far so good? Okay, good. Then now comes to the I will say slightly more difficult, but actually it's not, because you just have to follow this all the time, and then you have to fill up the power for the x and the plus 2. I mean, I'm writing the square there, so you have to fill up the small square with the power. Okay, so how do you get the power for the x term? I'm talking about the first term, okay? The first term. Okay, so this this power this power here, okay? So you need to fill up with, how do you get the power is, because your first term is 5 choose 0. Can you see? Here is 5 choose 0. So 5 choose 0, your this power of the x actually is 5 minus 0. So therefore you fill up with 5 here. Okay? And then when you fill up with 5 here, then therefore this has to be 0. Okay? Then after that, for the second one, what do you think? X to the power of? Yes, it's 4 because 5 minus 1 right? Okay, so if the x to the power of 4, then what is the power for plus 2? Can you make a guess? Yes, it's 1. By the way, there is a very quick way for you to check whether your power for x and 2, they are correct or not. So basically the power the power here is 5. So that means your this power for the x and the power for the 2, right? They add up to 5. Must add up to 5. So in a way, right, for the rest, right, is 3 and 2, and then 2 and 3, okay, and then this is 1 and 4, then this is 0 and 5, okay. Okay, then after that you just have to do what? You just have to use a calculator and then just get the answers, right? Okay, can you help me out? The first term, 5 choose 0, what do you get? 5 choose 0. We do it term by term first. Yeah, please. 5 choose 0, I think is 1, if I'm not wrong. Okay, it's 1. So x to the power 5 is 5. X to the power 5. Then anything to the power of 0 is 1. Okay, so it's 1 times x to the power 5 times 1. That's the first term. Second one, 5 choose 1, I think it's 5. Can you help me validate? Okay, it's 5. So x to the power 4 is x to the power 4. So plus 2 to the power 1 is 2. Okay, so basically you just follow the steps. 5 choose 2, I need your help. Yeah. Okay, 5 choose 2 is 10 times x to the power of 3. Then plus 2 to the power of 2 is 4. Okay, good. Then 5 choose 3. I'm doing the fourth term already. Oh, 5 choose 3 also 10. Okay, never mind. Yep. So we trust the calculator, okay? So if like, then you must be thinking, hey, 5 choose 2 and 5 choose 3, how come they are different? How come the result is the same? Okay, then you have to use the calculator and double check. If the answers are the same, and you have to accept it's the same. Okay? Then x to the power of 2, and then 2 to the power of 3 is 8. Okay, 5 choose 4. Okay, good. So x to the power of 1, and then 2 to the power of 4 is 16, right? Can you help me 2 to the power of 4? 16. 5 choose 5, I think it's 1. Can you help me out? Okay, so it's 1 times x to the power of 0, 1. 2 to the power of 5, 32. Okay, so far so good. Then you just have to 1 times 1 is, so the first term is x to the power of 5. Then you have 5 times 2 is 10, x to the power of 4. Then 10 times 4 is 40, x to the power of 3. Then you have this 80, x to the power of 2. Then you have this I think 5 times 16 is 80. Yes, so it's 80 x to the power 1. Then you have 32. And by the way, I really want you to use calculator. Don't try to do it using your mental calculation. I don't trust my mental calculation. But too bad I don't have a calculator with me. So when you have a calculator with you, please use the calculator all the time. Okay? Okay? Because sometimes our mental calculation just play tricks on us, and then we end up with a very silly mistake. While we can actually avoid that silly mistake. So that is the way you expand this x plus 2 bracket to the power 5. Okay? Okay? So just to give you some more advanced terms you need to learn in binomial theorem. So this is called the x to the power 5 term. Okay? Then this one, the last one, which is plus 32, right? This can be called a constant term. This can be called a constant term, or it can be called a independent of x term. That means independent of x means no x. So if next time if you see constant term or independent of x term, basically they want you to find the one without the x. Okay. So if you need to expand this x plus 2 bracket to the power 5, right? This is the after expanding you will get this result. But generally they will not ask you to expand the whole thing out because it's a waste of time. Okay. Generally they will just say, hey, let's say let's go to slide 14. Okay. So if I give you another question, okay, maybe this question should be a bit linked to the question that you asked me. I'm going to go to your question. Hold on first. Okay, good. Let's use your question. So let's say I have this. Okay, to the power of 6. So I don't want you to expand all. I don't want you to expand this. Okay. I just want the x to the power of 2 term. Can you give the x to the power of 2 term to me? Yeah. I am on slide 14. So maybe you can just carry on from slide 14, and I want to see how you get the x to the power of 2 term. Then we will tackle your question. Yep, you can. Yes. By the way, so okay, my question is, are you going to expand this into 7 term? Yeah, you don't, right? You don't. I mean, you can, but it's a waste of time, because the question just want the x to the power of 2 term. Alright. Okay. So I would like to see how you come up with the x to the power of 2 term first. Okay. I will leave it to you. If you face problem, then of course I will be by your side. Yep. Go ahead. How come the camera is still not on? Very funny. Let me see why. Yes. Yep. Yes. Hi. Yep, you can see me, I guess. You can see me already, right? Yeah, yeah. If you don't want to see me, it's okay. Yeah. What are you referring to? How to do the x to the power of 2 term? Pardon? Oh, that okay. That actually that is another method which I seldom use. Okay, so maybe let me just walk you through this example. Then later I will yeah. So you see okay, I can continue to use my method here, but of course um, you just learn it, and I don't expect you to understand it right away. Yeah, I don't expect you are so fast. Okay, so they want the x to the power of 2 term. So you see the x to the power of 2 term meaning what? Meaning I know that there is this term, okay, and every term is given by 3 brackets, right? You remember that? Okay, let's go to slide 13. Okay, let's have a good look at slide 13. Okay, so can you see that every term is given by 3 brackets? Okay, okay, so therefore when you are asked for the, let's go back to slide 14. So if you are asked for the x to the power of 2 term, right? So the x to the power of 2 term is the term that you must start with 3 brackets first. Okay, because every term has 3 brackets, right? And then what else is common? The next common thing among all the terms, right, is if this is 1, this is plus 2x, I have to fill up this second bracket with 1, and I have to fill up the third bracket with plus 2x for every single term, right? Am I right? And then I also have to fill up the first bracket with 6, choose something. Okay? So this is common. I mean, this format is common for all terms, right? Whether the question wants x to the power of 2 term, or x to the power of 3, or x to the power of 1, or x to the power of 0, they all follow this. They all have to look like this at first. Okay? Am I right to say? Yeah. So it's just like if you want to go to secondary school, then you have to go through primary school. But some people go to primary school, some people go to Queenstown primary school, but all of them, they have to go through primary school before entering secondary school, right? So similarly, whether they ask you for the x to the power of 2 term, or x to the power of 3, x to the power of 1, or x to the power of 0, they all have to look like this before before right at the start, right? Yeah. Okay, so this is what you need to start with. Okay, then now the actually the interesting part is, what do you fill up with? So what do you fill up into the small squares such that you will get the x to the power of 2 term? Okay, let's see. Yep, let's see. So yep, you said 6 choose 2, right? Yeah, let's see. So if you use 6 choose 2, and then this one will be 1 to the power of 4, and then this will be 2, right? Good. Yes. Yes. Okay, then you expand it, then you will see whether you will get the x to the power of 2 term. So can you help me out? 6 choose 2, what do you get? Hmm. 15, 1, 5. Good. 1 to the power of 4, 1. And then this one, the 2 will go to the plus 2, the 2 will go to the x, and then you get 4, and then x to the power of 2. And then if you use your calculator, it's 60 x to the power of 2. Yes, so this is the x to the power of 2 term, which is 60 x to the power of 2. Okay? And by the way, there is this term you have to understand. The 60 here is called the coefficient of x to the power of 2 term. Do you know that this is called the coefficient? Yeah. Okay. Yeah. So yeah. Sometimes they will say, please give me the coefficient. If you are asked for the coefficient, the answer is 60. Okay, if you are asked for the x to the power of 2 term, the answer is the entire thing, 60x to the power of 2. Are you clear? Good. So now, do you think you can solve your question? What do you think? Do you think you can solve your question? Mm. Mm-hmm. So basically, right, we practice. Okay, so never mind. Good that you asked. So basically, your question is more advanced. Okay, more advanced, but it doesn't mean it's harder. Okay, so let's continue from my this example. Okay, so I go to slide 15. Okay, 1 plus 2x to the power of 6. Okay, so the x to the power of 2 term is 60, right? Yeah. Okay, 60. Okay, good. So now you have, let's say I give you something, 1 minus x. So basically now you have, instead of just this, you have this. Okay, you have the product of these two. So you need to see the relationship between these two, the product of these two. Okay, so what you observe is, hey, if I have 1 minus x, and by the way, your this term, you will have 60x to the power of 2 plus, and by the way, you have other terms as well, right? which which I did not ask you to find out. Okay, which I did not ask you to find out because it's not necessary. Okay, so now if you look at this, that's why I use the plus dot 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 to represent, because your this thing your this expansion of this will result in 60x to the power of 2 plus the x to the power of 6, x to the power of 5, uh, x to the power of 3, 4, 3, 2, 1, 0. Actually, there are many more terms, but I just get this. Okay? So now, you see the interplay between this, the product of this. So your 1 will times this, that will give you 60x to the power of 2, right? Okay, good. So your 1 will times the let's say the x to the power of 3, so you will end up with, okay, this is a lah, or let's say, like, then you get a x to the power of 3. But do you need the a to the ax to the power of 3? Do you need this term, do you think? Why not? Yes. So in a way, right, that's why, because the question wants the x to the power of 2 term. Okay, even even with the product of this one. Okay, okay, so in fact, right, you need to cherry pick smartly. Ax to the power of 3 is not needed. Ax to the power of 4 also not needed, because, okay, by the way, 1 this 1 1 times anything is anything, right? Okay, so basically your 1 here, right, you just times the 60x to the power of 2. That's enough. You will get the x to the power of 2 term. And if you times the x to the power of 6, 5, 4, 3, 1, 0, I don't need that. Useless to me. Okay, but now comes the interesting part. Yes, in fact, you need the x term. Do you know why? Correct. Yes. So that's the way to look at this kind of question. That's the way to look at this kind of question. Your 1 will not. Okay, so the 1 times this will give you the x to the power of 2 term. Any other term, useless. But you have the minus x here. This minus x times the x to the power of 1 term, it will give you an x to the power of 2. So therefore, for this particular question, with time, I mean, if you multiply by this, you need to find out the x to the power of 1 term for this one also. Understand? So yeah, so can you get the x to the power of 1 term for the 1 plus 2x bracket to the power of 6 also? Can you do it on slide 15? Yes, please. Yes, go ahead. 6 choose 2 already done already, no need. because we did it previously, right? So now you need to focus on the x to the power 1 term. Yeah. Okay. I think you need to follow that format strictly. Okay. So can you start with 3 bracket first? Trying to fill up the bracket. Just start with 3 brackets, and then fill it up accordingly. So you always follow this procedure. Okay. So you always start with 3 brackets. Okay. So start with 3 brackets. Okay. Then fill up this two first, and then with the 6 here, and then they want the x to the power 1 term, so 1, so 5, 1. Understand? By the way, the order of what you write is important. Do you know why? Okay, just now you wrote this first, and then this second, and then this third. Do you know why the order? I mean, you did not follow the order. I mean, you did not follow the order. I asked you to do, right. Do you know why the order of writing this out is important? Not sure. Okay, never mind. But okay, I don't have an example at the moment. But later on, if you ask me other questions, maybe I should be able to highlight to you why the order of writing this thing out is important. So can you start to follow the order first? So what is the order? Can I delete this first? Can you just rewrite? Okay. You start with 3 brackets first. Mm, mm, and then, yep, 1. Very good. Correct. Yep. Yes. So in fact, right, you fill up this last, because these are 3 squares, the 3 small squares that you fill up last. Okay. The rest, they are common among all terms. They ask you for the x power 3 term, you will do the same. Okay. You understand? Okay, actually, right, you don't write the 1 first. I mean, you don't write the 6 choose 1 first. Actually, you should write this 1 first. Do you know why you write the 1 here first instead of 6 choose 1, the 1 there? Correct. So actually the order matters. So in fact, right, they want the x to the power 1 term, then actually you should note that, hey, x to the power 1, there is only one way I can get x to the power 1 is I have to fix this to be 1. So when this is 1, right, you know that this is 5. So if this is 5, you know this is 1. So in fact, the order of filling up the squares in this case is, it should be this way. 1, 5, 1. Like this way. Remember the order. The order of writing this is important. Okay? Okay, so next time, just remember the order, and then you should be able to solve all questions. Then, can you help me out? 6 choose 1. I think it's 6. Is it 6? Okay, then 1 to the power 5 is 1. Then this is 2x. Then this is 12x. Okay, good, 12x. Okay, then, yeah, pretty much done. So let's continue. So how do we find the x to the power of 2 term? Given there is a product of there is a product here, right? So basically you just do this. Okay, you write down the x to the power of 2 plus 12x plus dot dot dot. Okay, why plus dot dot dot? Because this expansion of this will end up with a lot more terms than the x to the power of 2 and x. But you don't want the other term because they are useless in this case. So what you do is just this, you get 60x above 2, and then your this one times this one will give you the minus plus minus 12 x to the power of 2. So can you see that you will end up with a 48x squared? Good. That's how you approach this kind of question. So do you think you can solve your question on slide 12, I think? No, 11. Okay, can you try this out on your own? So yeah, they want the x to the power of 2 term. So your question and my question, yeah, kind of like similar. Yeah. Very good. So maybe you just underline here, like to tell, like this is my x to the power. So you want x to the power of 2 first or x to the power of 1 first? Okay, so yes. So yeah, so just to highlight to yourself, hey, I want x to the power of 2 first, then x to the power of 1 later. Okay, continue. Yeah, very good. Very good. The order of writing it is correct. Mm, mm, very good. Yeah, yes. So you just have to use your calculator, get them out. Yep, you are doing good. You are doing good. Yes. Mm, So you need to continue to plus dot 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 plus dot 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 also, because you start with plus dot dot dot. Yeah, yeah. It's important to write plus dot 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 because your expansion of the this to the power of 6 is not just the x to the power of 2 and x to the power of 1 term. Okay. Okay, good. Yep, yep. Continue. Maybe you can write above here. I don't know whether you can delete your this what circular measure question or not. Just delete it if you can. Yeah. Yep. Yep. Good. So you just continue above. Yeah. Yeah. Okay. So what I see is you should get this. Then you just pick your this yeah, you need to pick 6ax plus, yeah, so you just multiply them, yeah, accordingly. Yeah. Mm-hmm. Yeah, done. Good. So you just take out the common factor x squared. Yeah, yes, continue. Yeah, just continue on ahead. Yes, but you see right now, hold on they say the result is 1 plus bx squared. The bx squared is actually equal to, okay, you can factorize this. Can you factorize this? Hold on if you, I thought you take 50, okay, a square minus 6a x squared. So you take the common x squared out first lah. Okay. So therefore, I think you can see that this is bx squared, right? So I think you can see that your b is actually equal to this whole thing lah, right? So it's 15a squared minus 6a. Oh yeah, yeah. Hold on. We compare term by term. Okay. So we are looking at the x to the power of 2 term first, right? Yeah. So now comes to the 1 plus. So what is this 1? What is this 1? This 1 is actually the x to the power of 0 term. Yes. So you also need to find out the x to the power of 0 term. Okay? Can? Yeah. So you, yes, correct. Because can you see that, okay, you actually this question I mean the result is 1 plus bx squared, No leh. I think in fact, right? Okay. Let me just give you a more flavor. Okay. So when you have one plus bx squared, right? You know what it means? It means let me just write let me just write beside here. Okay. Let me just go to slide 17. So if you have 1 plus bx, 1 plus bx squared, you know what it means? It means 1 plus, actually you have the x to the power 1 term, but it can be 0. I mean the coefficient can be 0. That's why the x to the power 1 term is not there. Okay? So therefore, in fact, I think you should get the x to the power 0, x to the power 1, and then x to the power 2 term out for the for this uh, where's the 12 11. So basically, right, for your this uh for your this, I'm on slide 11 now. So basically, right, for your this part, right, I think you need to get the 0 1 2 term out. Okay, yes, and then you need to get the x to the power 0 term. Yeah. Mm. Yep, good. Mm. Yes, good. It's also 1, right, I guess. Yeah, good. Yes, nice. Yes, good. Okay, good. So maybe we can erase this so that you have more space. Okay, good. So what you need to do right now is this. Hold on. So it's 1 plus bx squared. Okay, hold on. 1 plus bx squared. So what you need to do, right? You should get the 1 inside also. So you get the 1 inside. Then you have plus the dot, right? Then you just yeah. So your this times. In this one also times. Okay. So you have the 15a squared x squared then plus the 6ax plus 1. Yeah. Then you continue with this times this. Then you get, okay, this one don't need because this will end up with x to the power 3. Don't need. Then this one is minus 6ax squared. Okay, good. Then this minus x plus 1 is minus x. Are you clear? Then plus dot. Correct. Oh, yeah. Okay, because like I say, right, your this 1 plus bx squared, I will say is very, very tricky. Okay? Like, they hide the this, I mean, it's not there, but that doesn't mean it does not exist. Okay? You understand? The x to the power 1 term is actually there, but the coefficient is 0, so it make it disappear. Okay? Can? But still your this one is your bx square. Okay, so this one is still valid. Okay, this one is still valid. Okay, then the plus one is plus one, right? The what 6ax? Where's the 6? Okay, over here, over here, and over here. So because the 6ax minus x is equal to 0x. So the 6a minus 1 is actually 0, right? Okay? Yes. So with a equals to 1 over 6, then you can solve for b. Yeah, it's okay. No need. I think this is too easy. I mean, you just sub in and then you get the B. Okay. Okay. But this question I like it because this is the very important um, term that a lot of students might miss out and then they don't get the value of A. Okay, by the way, you are asked to find the value of A and B, right? So two values, so you need to have a simultaneous equations, right? Yeah, if you don't have a simultaneous equation, then you cannot solve. But because this is just one equation, so this is your second equation. So how do you get the second equation? In order to get the second equation, you need to know that A, actually the x to the power of 1 term, the coefficient is 0. Okay? Understand? Okay? So next time, if you see 1 plus bx squared, don't assume that, try to see actually the x to the power of 1 term is there, but the coefficient is 0. Okay, good. Yep, so we find the value of A and B already. Okay? Good. Do you still have other questions than this one? Okay, good. Go to slide yeah, the slide 17 please. Oh, you don't have any electronic materials. They are all like paper on a piece of paper. Oh, okay, okay. Oh, why because I thought other schools they have a hybrid model already. Mm. HBL. Mm-hmm. Ah, uh-huh. Oh, yeah, yeah, okay. Okay, okay, okay. So you guys don't use iPad and then you don't use iPad or what Chromebook to do homework online or all those things? What I'm trying to say is like, do you submit your homework electronically or you submit your homework in paper format? A long time ago. Okay. 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 Oh, okay. 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 Yeah. Okay. Thanks. Thanks for telling me. Yeah. Mm. They just write everything below lah. Mm. Yeah. Yeah. I think you need to expand this out in every single term. Yeah. Let's do the expansion first. Let's do the expansion of this. They ask you to expand. Yeah. So what I want you to do is always yeah. So just you need to manage your space also lah. Oh. 1 2 3 4 5. Oh, more already. Okay. Sorry sorry. So you manage your space lah. So what I generally would like what I generally will do is I will just start with this first, so that I know like I can manage my space well. 1 2 3 4 5. Yeah, good. Then only I will fill up with brackets. Mm. 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 Then you fill up with the 4 first. Okay. Then what's next? No, actually, truth. Okay, okay. If you are not asked to find a particular term, right? What is actually the first term? Is always 4 choose 0. Then what? Yep, correct. So 0, 1, 2. Then you just 0, 1, 2, 3, 4. Just fill it up. Very very mechanical, right? Like a robot. So this one will be over here. The 4 you fill up here, or you should fill up the here. Does it make sense? Okay, so you 4 choose 0, right? Actually, 4 choose 0, your this one, hold on. Okay, how I look at this is like this. 4 choose 0 already, so the power for the 1 is 4 minus 0. So I get 4. That only here is 0. Yeah, okay? So that's how I remember, okay? Mm. It takes a while, like, it takes a while. I agree. Mm. Oh, okay. Okay, by the way, okay, you stop for a while first. Can you see that they start with the power 4 first, and then 3, right? So basically, this is descending order. But what we are doing here is actually ascending order. But it's okay. So later, after you finish, right, you just reverse. Yeah, switch. Rearrange. Rearrange. Mm. Can you rearrange it? Then you can compare like it's quite similar. Can you see that your plus 1 is plus 1, and then your x is actually this one. So basically your x, right, your x here actually is this one. Okay, so you just replace your x with, so your s, this is s, right? So s is equal to 1 minus this whole thing. Hey, hold on. If it's x, then this is the whole thing. Or, okay, or you are trying to tell me it should be this. Hmm? Okay, then what answer you propose? Hmm. Maybe you can write it here. Mm-hmm. No, they ask you to find s, right? And make hands. Yes, so what I'm trying to say is, yeah, so I think you kind of like get it. So basically you say, okay, so by comparison means these two you compare. So you compare, right? Okay, this one will give you this, right? So x is actually your 1 minus x to the power 3, right? So therefore you just, so therefore 1 minus x to the power 4 is actually 1 minus 1 minus x to the power 3 to the power 4. That is your s, right? Simplify what? You mean this one? I think you need to do a bit of simplification, because I think you can simplify into a very neat answer. Do you have answers? Oh, okay. So x to the power 7. Okay. Alright. That's the final answer, like, if you simplify. But in fact, right, I think they want you, they want to see the workings as well. You cannot just like give it right away. Okay. Yeah. So yeah. Yes. Okay. Good. Okay. So time to take a rest. Yeah. Yep. Sure. Time to take a 5 minute break, and we'll come back. Okay. Okay. Good. See you in 5 minutes.